So today we are going to discuss the second method, and this is called the graphical method. And this is linked with the previous one. And in the previous integration method, we derived this very basic equation, and this was the concentration of A at any time equal to minus K minus this is the rate constant for the zero order action. This is the time, and A naught is the initial concentration, or you can say this is the concentration at time zero. So both are the concentration, but the difference between this A from this A is this is the concentration at the start, that means at the zero time, and this is the concentration after the start of the reaction, that means other than the zero, and it depends how much it is going to be prolonged. So again, if the value of K is remains constant, then it shows this is the integration, it is a zero order action, and this way of explanation is called the integration method because we are using the integrated equation. And this graphical method actually is linked with the integration equation. Now we are using the same equation to explain the graphical method. So why it is called the graphical method? Because here we are plotting a graph. That's why this is called the graphical method. So any method which information or the final conclusion is coming out from after plotting a graph, that method is called the graphical method. So that's why the reason behind this one, why we are saying this is the graphical method. Now, second important point is what to plot over here. So we are using the same equation, the integrated equation, which we derived before in the previous lecture. So here in chemistry, we use two equations. One is the actually these two form of the straight line equation. So why I'm calling it the straight line? Because here you can say this is the straight line, and even passing from anywhere, it is in the downward, maybe it will be the upward, passing through the origin, and all these equations are the straight line equation. So as I have explained, there are two forms of the straight line equation. One is with the intercept. Intercept mean it is not going to start with zero. So as you see over here, this is the time zero. So, and this line is not starting from the zero. So that means this is the straight line, although this is the straight line, but it is with the intercept. That means it is not passing through the origin or the starting at time zero. So this equation is called the also called the straight line equation with intercept. So how can you first explain? I'm giving you a very basic information. How can you identify that this equation is the straight line equation with intercept or without intercept? So this is you can do by generalizing the concept, which I am going to explain over here. So the first look at the equation. So these are the some of the parameters are given over here, which I have already explained. So this is I am naming this is the so this is the first I am going to explain how can you identify the equation, and then I will say whether this is the equation with intercept or the without intercept. The first thing is this is one of the variable over here. Okay, you can say this will remain the constant because this is the initial concentration, and this will remain the same concentration as you can say if you are starting the reaction with 1 molar concentration, that means A naught would be 1 molar concentration. So this is not going to change. That means this is the constant. Again, this is the rate constant. It will remain the constant. So there are only two variables are here. This is the concentration of the reactant A at time t, and this is the time. So when time is changing, the concentration is going to change. So that means these two are the variable. So if you have a look at the graph, in the graph, we have also only two variables on the y-axis and on the x-axis. So again, there in this equation, there are only two variables. So one should be on the y-axis and one should be on the x-axis. Now the question is over here. So please listen carefully because these are the generalized statement. It doesn't mean this is only for this equation. This may be for all equations. And as a chemistry student, and you must know how to define these variable coming out of any equation. So again, these two are the variables, and now you have to decide which variable should be on the y-axis and which variable should be on the x-axis. So why this on the y-axis and the time on the x-axis? I've given away time on the x-axis and a should be on the y-axis. So the reason or the answer to this question is one variable is the dependent variable and other one is the independent variable. Like here you can say the time is the independent variable because it doesn't matter the concentration will change or not change. If it is a zero order, second order, or the third order, time will not stop. Even you learn this course or you do not learn this course, even you can do good things or the bad things. So time is not going to stop. So this is going on. So that means this is the independent variable. So what is the dependent variable? The concentration may depend on the time. Your activities may depend on time. So these are the dependent variables. So dependent variable must always be on the y-axis. So independent variable must be on the x-axis. So this is the reason why we have plotted the time versus the concentration over here. Now again decide. So this is the one of the variable. Now what is the why this is the m and this is not the m, you can say, and why this is c, this is not the c. That means this is the intercept. The constant here, it is the intercept we are talking about. And again, the answer is very simple. Any constant that is going to multiply with the independent variable, that constant must be the slope of this straight line equation. So that's why written over here. This is the m multiplied by x, mx. That means m there is a constant that is going to be multiplied with the x, and that constant must be a slope. And there is another constant, and this is the without multiplication of any of the variable. So it is alone, you can say this is alone, and that constant is called the intercept. So you can easily now identify or why this is the this will be on y-axis, this will be on x-axis, why this is called the m and this is called the c. So whenever the equation is written, first you can decide this should, let's suppose it is the m, and even if you unable to differentiate which is the variable or the or the constant, just have a look, there should be a two values, and one must be a variable, other one should be a constant, and these must be along together, and that's why these are called the mx. If this is the x, it must be m. So the rest one is the constant, that is called the intercept. Now I'm going to plot a graph and defining that why this is the how to determine the order of the reaction by using the graphical method. So how you are getting the information that this is the zero order reaction. So question and the objective is this. So the first you have plotted this A versus time as given in these variable. So this is the time zero. And when time is zero, the concentration on the y-axis would be the A naught. And this is the same because this is the only concentration at time zero, as I have explained before. So at time zero, the concentration would be the A naught. And what would be the intercept from here, from this point to the 0 point on the y-axis? This is called the intercept. So that means from 0 to here, you can calculate if I'm labeling this is the point 1, this is the point 2, this is the point 3. So the intercept will be the point 3, and that means I am starting the reaction with the initial concentration of the point 3. So you can determine the initial concentration even from the graph if you do not know the initial concentration at the start. So this we have done with the intercept. Now look at the graph. As soon as the time is going to increase, the concentration of reactant will decrease, of course, and this is the how the rate is related to the concentration of the reactant. As soon as the product is formed, the concentration of reactant is going to decrease, and as soon as you increase the temperature, the concentration is going to decrease, reaching at the sum of the point, and that's why it is going to be downward. So downward is coming from the data, and also if you have a look at the this m is multiplying with the minus sign. That means here the slope is negative, and this is the slope in negative. If it is coming down, it must be a negative. And if you see any of the equation without minus sign, that means it must be a positive slope, and then it may be passing through the origin or from the any point, but it must be coming upward. So like you are moving upstairs, it is the positive slope, and when you are going to downstairs, this is the negative slope. So this is from the this one graph. So now coming to the final conclusion, that uh, how you can say that this graphical method is for the zero order action. Again, now, this is very important statement. If you plot a graph, your answer would be, if you plot a graph between A versus time, the concentration of reactant versus time, so these variable only for the zero order reaction as given over here. And as I have said before, you must be very confident this, if this equation is for the zero order reaction, there will not be any other equation like this. And here the variable, if this is the y, this is the time, this graph is only for the zero order action. So your statement will be, you will say, if the graph is plotted between the concentration of the reactant and the time with the negative slope, giving you the straight line with negative slope, that means it will be a zero order action. And what would be the answer if it is not a zero order action? You can say, in the same way, if you plot the concentration of the reactant A versus time, and if you will not get a straight line like here, in other case, if you will get a curve, like it may be like this, if you are getting curve, and then it is not a zero order reaction. So again, I'm repeating this statement. The graphical method, how would you get uh, the verification or the method to determine the order of the reaction by using the graphical method? And the answer is, if you plot a graph between concentration of reactant versus time, and you will get the straight line with the intercept, then it is called the zero order action. Or in other case, if you get the curve, that means it is not the zero order action. So this is the statement as the same we have made in the integration method.